Hello students, welcome to today's lecture on PPSUC. In our previous class, we have discussed about how parameters can be passed to function, and we have gone through two types there: call by value and call by address. And also, uh, we have discussed about several types of functions based on different ways of defining the return types and arguments. Okay. And as continuation to the functions concept in C language, today we will discuss about the recursive functions concept. Okay. So let us see what is a recursive function and then how it is different from an iterative function which we wrote till. Okay. So the definition of recursive function is very simple. Function is said to be a recursive function if the function calls itself. Okay. If the function calls itself, then we call it as a recursive function, right? So that means we can specify this definition in other way also. We know that there will be two types of functions. One is a calling function, which calls another function. The second function, which is called by other function, is called function. Okay. So if the calling function and the called function are same, then we can call that corresponding function as a recursive function. Okay. Or simply you can remember a function is said to be a recursive function if it calls itself. The function calls itself. And there may be two ways to call the function by itself. Either it may be directly or it may be indirectly. So based on this, whether it is calling directly or indirectly, the recursive functions are again classified into two types. One is direct recursive function, which falls into this category, and the other one is indirect recursive function, which falls into this category. Okay, so let us have a look at what is a direct recursive function and what is an indirect recursive function. So this is the definition of direct recursive function. A function is said to be a direct recursive function if a function calls itself from its own body. Okay, so you need to remember this, from its own body. Okay. That means assume that f1 is the function we are defining, and in the body of f1, if the function f1 is again called, look at the name of the function. It is f1 and it is calling itself. Okay, so it goes back when the function calls itself, then the execution again goes back with specified values. So if you have something like this, a function is calling itself from its own body, then we call the corresponding recursive function as a direct recursive function. So in this case, the function f1 is said to be direct recursive function. Okay. Similarly, the second category of functions is indirect recursive function. A function is said to be an indirect recursive function if a function calls another function, which in turn calls the first function. That means the function calls some other function, that other function again calls back the first function. Okay. If such thing happens, we call it as an indirect recursive function. Okay. Now, if you look at the example, say f2 is a function, it is calling f1 from its body. Okay, and then so it is calling f1. Now, if you observe the body of f1 now, it is calling f2 from the body, from its body. That means it is calling f2. So if something happens like this, if a function calls other function, which in turn calls the first function, then we can say that they are indirectly recursive function. F1 is an indirect recursive function, and if you observe this F2, it is calling F1, and F1 is in turn calling F2. Therefore, F2 is also an indirect recursive function. Okay, so either F1 or F2 both will be treated as indirect recursive functions. Okay, So the difference between direct recursive function and indirect recursive function is, in direct recursive function, the function calls itself from its own body, whereas in indirect recursive function, function calls other function, which again calls the first function. Okay, so this is called indirect recursion. So these are the definitions of direct recursion and indirect recursion. It is very easy to remember the theory part of recursion, but is not so easy to understand the recursive functions programs. Okay, let us go through few examples, very important examples that makes use of a recursion concept. The first program I'm going to see is, I want to find out the factorial of a given number. Okay, so this program is for calculating the factorial of a given number. Okay, so we already wrote some program for calculating the factorial by using a loop. Therefore, it is called as a iterative factorial function. Okay, in our last class, we have gone through that factorial program. I have explained it. Uh, Now, I want to find out the factorial of a given number, but not using a loop. This time, I want to use a recursive function. Okay, so as we all know that the n factorial can be defined as the second formula is there for n factorial. We can calculate n factorial by using a recurrence relation, which is called as n into n minus 1 factorial. Okay, so n into n minus 1 factorial. So this is another formula for calculating n factorial. If you observe this formula, the question is what is n factorial, and the answer is again n into n minus 1 factorial. So the answer is defined in terms of the original problem but reduced. Originally it is n factorial, now it is n minus 1 factorial. Okay, so n into n minus 1 factorial is a recurrence relation that defines the n factorial formula. Okay, so we are going to make use of this concept to implement the recursive function for calculating factorial of a given number. Okay, so let us understand this. So this is the function definition. Int fact of int n, which means we are going to send an integer value as parameter to this fact function, and this fact function will calculate the n factorial value and throws back the corresponding result. Okay, to understand it carefully, what are the values that we know? We know that 0 factorial is equals to 1. Okay, so you should understand the base case of any problem that is going to be solved using recursion. And we also know that 1 factorial, the minimum values that can be calculated directly without using any formula. That is 1 factorial is equals to 1. These two are treated as base cases for your factorial function. Okay, therefore, we make use of this condition over here. If n is less than or equals to 1, then we can say that the factorial value is 1 directly. So you don't require any calculation here to say the answer for 0 factorial and 1 factorial. So we directly return the corresponding answer. Okay. Otherwise, if n value is greater than 1, then we need to calculate it using the formula. What is that formula? N into n minus 1 factorial. That means factorial of n minus 1. Therefore, if you observe this, the same function, what is the name of the function? It is fact. The same function is called with parameter n minus 1. Previously, we sent n here. Now it is n minus 1. Okay. So this function somehow returns the final value of the factorial for n, for given n. Okay. Now let us go back to main function. How this function is called. So int n comma res, two variables are declared here, and I'm asking the user to enter any number, and the corresponding value is stored into n. Okay. Now the function is called like this. So if you observe, There is no difference in declaration of the function and calling of the function. There is no difference at all. So what is difference from the iterative function and recursive function? If you observe this, the recursive function definition is different from iterative function. In iterative function, we will make use of loops over there, whereas in recursive function, we will call the same function again and again to implement that or to get that loop impact. Okay, so we call the function as res is equal to fact of n. After completion of this recursive function, the final result will be uh, thrown to this particular location. Okay, and the result will be copied to res. Okay, so the result comes over here and it will be stored into this variable res. Okay, and now the result res stores the final value of factorial. So I'm printing that value. Factorial of given number is percentile d comma res. Okay. So if you look at this program, it is very simple to understand the program, but you may be confused about how it is actually calculating the final value of the given n, the final factorial value of a given n. Okay, so to understand this, let us go through a sample tracing of this program for n is equals to 5. Okay, so let me show you what will happen if n is equals to 5. So if n is equals to 5, fact of 5 will be calculated first. Okay, so fact of 5, that means uh, n value is 5 and it will invoke fact of 5. N is 5 here, and then the control goes over here. So now the execution begins from here. Fact of 5 is the first term. Okay, so fact of 5 is the first term. Now what happens with the function? It will check what is the value of n. N value is 5, therefore 5 less than or equal to 1. The question is no. That means it returns false. If this condition is false, then the control comes over here. That means it enters into else part, returning this n into fact of n minus 1. That is 5 into fact of 5 minus 1. That is going to be 5 into fact of 4. Okay. So now if you observe, this is again a function call for fact of 4. Similarly, it returns 4 into fact of 3 for this. Okay. 4 into fact of 3 for fact of 4. And then fact of 3 is again a function call. So it is again divided into 3 into fact of 2. Okay. Again, fact of 2 is a function call which will be divided into 2 into fact of 1. Once we reach this fact of 1, we know that if n is equals to 1 or less than 1, okay, we know the answer as 1. So it returns the value now. It returns the value which is replaced over here. Okay, in place of this fact of 1, the value that will be returned is 1. So now this multiplication is performed. What is the result? 2 into 1 is performed, which returns 2. And this entire value, what is the entire value? 2 into 1 is the entire value. So this goes back. Okay, that is 2. It goes back to the previous step. Now fact of 2 is now 2. Okay, that is the value we got. Fact of 2 is divided as 2 into fact of 1. Because we calculated as fact of 1 is 1, 2 into 1 becomes 2. This comes back over here. Okay, now it is 3 into 2. So the result of this entire expression is 6, which is the value for fact of 3. Are you following? So the value of fact of 3 is 6. How it came? It is 3 into fact of 2. Because fact of 2 is 2, the value is going to be 3 into 2. So it is coming back now. Previously, the function calls are forwarded like this, and once the base call is returned a value, it is coming back with the calculations tracing towards the first call. Okay. So now what is the result of 4 into 6? Okay, this entire value is 4 into 6. That means 4 into 6 is 24. That is the value of fact of 4. Okay, so this fact of 4 gets a value 24. Now, this 5 into 24 results in 120, which goes back to that first call. What is that first call? Fact of 5. So the fact of 5 is going to be 120. So this is the final result returned by your function, recursive function, and this is how it works. Recursive functions works like this. If you observe, it is very difficult to trace out any given recursive function. It's very difficult to understand that tracing, but it's very easy to write the program since we know the base condition and the remaining condition. This is called base condition if n is less than or equal to 1, and this is called the recursive step. Okay, so base step must be properly defined and recursive step must be properly defined. If you know these two without knowing much details about how it actually calculates the factorial value, you can simply write the function. Okay, so that is why recursive functions are very easy to write but difficult, very difficult to understand. Okay, so we experienced this with the first program, factorial of a given number. Okay, next we'll continue with few more examples. Another very important example for understanding the recursion concept is generating Fibonacci sequence or Fibonacci series. So what is a Fibonacci sequence? So we need to understand that first. Fibonacci sequence goes like this. The first value is 0, it is fixed, and the second value of the Fibonacci sequence is 1. These two are fixed. Okay, first value of Fibonacci sequence is 0, second value of Fibonacci sequence is 1. First two values are fixed. Okay, and from the third value onwards, the value is calculated as a sum of previous two numbers. So what is the third value? It is 1 plus 0. That means the third value in Fibonacci sequence is 1. What is the fourth value in Fibonacci sequence? 1 plus 1. That means it is 2. And what is the fifth value in Fibonacci sequence? It is going to be 2 plus 1. That means it is 3. And what is the next number? It's going to be 3 plus 2, which means it is 5. And the next number is 3 plus 5. That is going to be 8. Next number is 5 plus 8. That is 30. And this sequence goes like this. Okay. This is called Fibonacci sequence. The first two numbers are fixed. Okay, and the remaining numbers are calculated as sum of previous two numbers. So this is what we are going to use. Therefore, the termination point is if n is equals to 0, return 0, because that is the first number in Fibonacci sequence. Else, if n is equals to 1, then return 1, because that is the second number in the Fibonacci sequence. Else, return. How do you calculate it from the third number onwards? It is sum of previous two numbers. So assuming that this is fib of n, it's going to be fib of n minus 1 plus fib of n minus 2. Okay. So n minus 1th term, this is n minus 1th term in the Fibonacci sequence, and n minus 2th term in Fibonacci sequence. The sum of these two will be written. Okay. So this is the function fib of int n. Again, it is calling fib of n minus 1 plus fib of n minus 2. This function is calling the same function twice in the body. Therefore, this type of recursion is called, because it is calling two times, this type of recursion is called binary recursion. Binary recursion. Okay. So now let us understand how it works. Initially, I'm declaring the function int fib of int, it is same as this function header. And in main function, I'm declaring two variables, one for entering a number. So ampersand n stores the value of the number of terms to be generated in the sequence. For example, if it says 5, the first 5 numbers must be generated. Okay, and so on. So for generating, what I will do is based on the n value given, for I is equals to 0, I less than or equal to n, I plus plus, and percentile d fibo of I. Actually, this is not I less than or equal to, I less than n is sufficient because I is starting with 0. Okay, so fibo of I. Then for every I value is 0, then it calls fibo of 0. It means it returns 0. Okay, when I is equals to 1, it calls fibo of 1. It means the value of return value is 1. So it displays 1 over there. And if I is equal to 2, then it comes over here and returns fibo of 2 minus 1, that is 1, plus fibo of 2 minus 2, that is 0. So what is fibo of 1 plus fibo of 0? It is 1 and 0. Sum of these two is 1 plus 0 is 1. So it displays the corresponding value and so on. Okay, so this is how it calculates the Fibonacci numbers for a given I and returns back into the printf for display purpose. Okay, so this is the program for uh, generating the Fibonacci sequence. Right. Now let us understand this with some pictorial representation. So I'm just showing how the function calculates for fib of 3. I'm showing that fib of 3 only. So for fib of 3, it will be divided into fib of 2 plus fib of 1. Okay, so the formula is fib of n minus 1 plus fib of n minus 2. Fib of n minus 1 is fib of 2, fib of n minus 2 is fib of 1. Okay, so assuming that this 3 is n minus 1 becomes 2, n minus 2 becomes 1. Okay, and then again this function called fib of 2 is divided into fib of 1 plus fib of 0. Okay, in either way you can write. Actually, it is fib of 1 plus fib of 0. Now it is fib of 1 uh, is equals to 1. We know that fib of 0 is equals to 0. 0 plus 1 is going to be the result of fib of 2. So what is it? 0 plus 1 is equals to 1. And as we calculated this value, fib of 1 is always returned as 1. Okay, that is the base case. So once this is 1 plus this is 1, 1 plus 1 is going to be 2. So the value of fib of 3 is 2. That is how it calculates. Okay, I hope you understood now. Uh, you can calculate how fib of 4 will be evaluated. You can draw a diagram, and for fib of 5 also try to trace out the value by using this division of function calls. Okay. So this is about the second important program, recursive function for generating Fibonacci sequence. And one more example program I want to discuss. That is to find the sum of first n natural numbers with the help of recursive function. We wrote an iterative program for this also. Now we will see how it can be calculated using recursive function. Okay, so first n natural numbers. For example, I want to find out first 5 natural numbers. So it is calling find sum of 5. That is, I want to find out the sum of first n natural numbers. That is first 5 natural numbers. What are they? 1, 2, 3, 4, and 5. So the sum of these values. Okay. So initially I'm calling it as find sum of 5. So the first call is find sum of 5. Okay, let me write it as f of 5. I cannot write that entire thing. So I assume that f of 5 means that find sum of 5. This is the first call. So the control is transferred now. to the function definition. So that goes over here with a value 5 for this n. So initially it is 5. If n is equals to 1, no, n is 5. So this will not be executed. Therefore, the control comes over here. So what it is saying, it is returning n plus find sum of n minus 1. What is n? It is 5. So the result of this is going to be n plus, that is 5 plus find sum of, that is function of n minus 1, which means it is going to be 4. So f of 4. Okay, so it is 5 plus f of 4. Similarly, because f find sum of 4 is again a function, now it is calling the same function with another n value, which is nothing but 4. So what will be returned here? F of 4. Is that 4 is equals to 1? No. Therefore, again it comes over here. So this will be now 4 plus f of 4 minus 1. That is going to be f of 3. Okay. Again, this f of 3 will be split into 3 plus f of 2. Okay. Now, again, we don't know what is f of 2. So 2 is equal to 1 is false. So it splits again. So f of 2 is again split into 2 plus f of 1. Okay. So when this function is called, f of 1 with n value is equals to 1, this 1 is equal to 1 will be true, and then it returns 1. At this point, we got a value for f of 1. Therefore, this will be replaced by 1. Okay, the result of f of 1 is 1. Now, the result is 2 plus 1, which will be forwarded to f of 2. That means the value of f of 2 is 3. So 2 plus 1 is 3. Now 3 plus 3 is the value of f of 3. So it comes over here with the value 6. Now it is 4 plus 6 is the value of f of 4. So f of 4 is replaced with the 10. 4 plus 6 is 10. Now 5 plus 10 is the value of f of 5. Therefore, the value of f of 5 is going to be 15. That gets displayed over here. Okay, so this is how it works. Okay, so you practice this example with some other value here. Find sum of some 8, something like that, and you try to trace it out, try to understand. Don't worry, even if you don't understand this tracing point, because recursive functions are very hard to trace always, but you need to understand how to write the recursive functions by knowing the base function, the base condition, and the recursive condition. Okay, so that's what you need to understand, right? And having seen a few programs till now, let us understand what are the advantages and disadvantages of recursive functions compared to iterative functions. But there are few advantages for the recursive functions. The first one is the size of the code will be reduced. As we saw, very few lines of code will be used. Okay, so there is actually a beautiful example to understand this, where even iterative function not even possible for a bigger n values. That problem is towers of n. I will go through that problem in the further semester in the subject data structures. Okay, so in such case, we can see that a recursive function helps us to write the code very easily by knowing the uh, base step and recursive step. Okay, so that is the first advantage. The second advantage is we can easily write recursive functions without knowing much about the details of programming. Okay, so we don't need to know how exactly it calculates internally, but what we need to know is how to represent that recursion step, uh, recursion step for solving the given problem. So that's what we require. These are the advantages with recursive functions. And the second thing is disadvantages of recursive functions. There are a few more. It's very difficult for the programmers to trace a recursive function manually, as we saw it earlier with the examples. It's really hard to understand that tracing process. And the second thing is the space complexity of recursive functions is more when compared to iterative functions, because every recursion step, whenever you call that function, every call will be stored into a stack as an activation record. Therefore, the same variables are stored again and again as activation record into the stack, occupying more space. Okay, so that is a disadvantage of recursive functions. And also, uh, the time complexity of recursive functions is more when compared to iterative functions. The reason is very simple. Uh, it stores the uh, activation records into stack, and retrieving the values of variables from activation records and analyzing them, substituting them, calculating them between the recursive calls is always going to take much time compared to iterative functions. Okay, so these are the disadvantages of recursive functions. Right. So I hope you understood the recursion concept, and now uh, try to practice more examples uh, that makes use of recursion. Okay, so we'll see some other example programs in our lab session also. I will explain more programs when we discuss about lab session. Okay, so that's all for today. What we discussed today is we have gone through what is a recursive function and how it is different from a regular iterative function. Then we have gone through the types of recursive functions as direct recursion and indirect recursion. Then we have seen uh, some very important example programs implementing this recursion, starting with factorial of given number, and then generating Fibonacci sequence, and then sum of first n natural numbers, right? So we have gone through these examples, and finally we discussed about what are the advantages and disadvantages of using recursive functions. So that's all for today. Uh, we will discuss about the remaining topics of fifth unit, which are the storage classes concept. Actually, it is available in first unit, but we did not discuss about the storage classes much in first unit, as we require the knowledge of functions. Now we have sufficient knowledge about functions. Therefore, we are now capable of discussing about the storage classes. So in tomorrow's class, I will discuss about the storage classes used in uh, C language. Okay, that's all for today. Thank you all for your patient listening. See you again in the next class.